next section, and hopefully it won't be too long. So today we're going to focus in on some vocab, modulus, argument, and compare and contrast those to vectors. So since we've already did vectors, these should be pretty straightforward. It's very similar. So when we talk about modulus of a complex number, we're really just talking about how long is it. So it's asking this length right here. How long is that? Which is just like when we did the magnitude of vectors. So it's the same procedure, all of that. Things to be aware of. If you're doing A plus BI, we're only taking the number part of each component. So if I had 3 plus 4i, you would do 3 squared plus 4 squared, all square rooted. You can just ignore the I because the I kind of functions as like a label. So you don't really need to think about that when you're finding the magnitude. So the notation you're going to see for modulus is just like the notation we see for magnitude, which is that absolute value signs. So if you were doing this one, you would say 7 squared plus negative I is just 1 long. So you're looking at like a complex number that's 7 over, 1 down. It's like here. So this is 7 and that's 1. So really you can ignore the negatives when you're thinking about modulus or magnitude when we're talking about vectors, because the positives and negatives are more indicative of like direction than they are in terms of length. So this would just be 7 squared plus 1 squared, which is going to give you square root of 49 plus 1 is 50. So you could also do like this one down here. Negative 4 would be here. Negative 8 would be like down here. You're looking at this guy, right? But we don't really care so much about the negatives, so we can just do 4 squared plus 8 squared, square rooted. So 16, 64, I can add, yay, 80. So you can always do it like that. You don't have to put it into your calculator and get a decimal version. Actually, the radical version is more specific, so you can always just leave it in that form. But when you do check these on a calculator, it's always going to give you the decimal version unless you have a CAS. I think the CAS might give you the radical version. The other thing we talk about is argument, and argument is just talking about the angle of rotation. So how far is it from 0, which is always this starting line here. It's the same thing with vectors. It's how far is it from that component. So argument is to complex numbers as direction is to vectors. The only thing you're going to want to be aware of here that's a little bit different is that the angle / the argument is always going to be in radians. So if you had your calculator in degree mode, it would give you just like an error code. It wouldn't actually find the angle for you because it always has to be in radians. So if you're looking at this one, right, you're saying it's going to be somewhere between 0 and pi over 2. If you're in this region over here, it's going to be somewhere between pi over 2 and pi. Down here, it's going to be between pi and 3 pi over 2. Here they have it noted as negative pi over 2. That's fine also. And then last would be 3 pi over 2 back to 2 pi, or again 0 back to negative pi over 2 / negative pi over 2. Either of those is fine. So let's look at these ones right here. We'll do a quick little simple one. So this one right here is 2 plus 2i. This is going to go back to last year when we were thinking about like unit circle. If this is 2 and this is 2i, and that means they're the same, right? You're talking about like a 45-degree angle. So 45 degrees, but again, we can't make them be degree mode, so we have to make it into radians. So this would be the same as if this is pi over 2, well then that's half of it, pi over 4. And again, your calculator will give you a decimal version for all these. So if you wanted to check your answer, it would always be in decimal form. So this one over here, 2 and then negative 2i. I don't think that diagram actually goes with that. I think they're flip-flopped here. 2 and negative 2i. That guy actually goes down here with this one. So this one right here would be negative 2 and positive 2i. So negative 2, we're going to just change it, positive 2i. But again, still just that 45 degrees past 90. So you have pi over 2 and pi over 4 more. And that's going to give you 3/4, right? 3 pi over 4. And if you ever forget how to do that, right, this with this, you can just kind of ignore the pi and say, well, what's 1/4 plus 1/2? Well, that's 3/4, and then go back and add your pi and think of it sort of as like a variable more than a number, and that can help with the operational part. Okay. The last thing for this section, is how to find modulus and argument using your calculator. So we're going to look at that here on the actual calculator here. But just for your notes, it's going to be under number. And then there's a whole bunch of complex number tools. And then this section right here is going to pop up. And it's going to say magnitude because, you know, of course it wants to be confusing. But magnitude is, again, same as modulus. And angle is the same as argument. I'm not sure if it's a TI Inspire thing. I'm not sure if it's an international way of talking about complex numbers versus an American way. I'm not sure what the difference is in terms of the notation or the terminology, but that's what you're going to use. So magnitude is to modulus and polar angle is to argument. So let's do this guy down here. So this is going to be 2 minus 2i for this guy. So we go to our calculator and we go 2 minus 2. You got to use the I down here or it won't work. Whoops. No, it's not going to work anyways for me. There we go. And then hit enter. And it's just going to, well, it turned into polar form for us, but we're going to ignore that for now. And we're going to go to number. And then we go to complex number tools and we're going to say magnitude. And it looks like it wants us to do it this way. Copy and paste. And it gives us this number right here, 2.83. And then you could do the same thing. Menu, number, complex numbers tools, and then angle. And again, boom, enter. It's giving it to us as this negative value. So they're thinking about it as like a backwards rotation. So rotating backwards this amount of radians. And again, it's in radian mode. I'm going to just really quickly show you. If I change this to degrees and then I go here and I hit enter, oh, it did give me negative 45, but a lot of the time it will come up with an error, particularly in the in some of the other forms of complex numbers that we'll look at later on. But just be aware that IB always wants the answers in radian form. And if you feel compelled, you can do, I would do maybe some of these practice questions down here. Make sure you feel comfortable finding the modulus and the argument of some different terms. Just, again, it's just Pythagorean theorem. It's just SOHCAHTOA. So you could do these. I'll come back here really quick and look at an example. Let's maybe pull like a yucky looking one. Here's one from the homework. It says 2 root 3 plus 4 root 6i. Well, that's super gross. So we're going to do that one really quick. Let's say this one's here and then this one's like up here. And so our complex number is there. So 2 root 3 is this one. 4 root 6 is this one. You're looking at that angle right there. So you're talking about opposite, adjacent, adjacent. And so you could use tangent here to also find that. So you could just do tan of theta equals 4 root 6 over 2 root 3. Or you could just pop this right into as tan inverse of this side, and it should give you an angle. So let's really quick make sure we get, we'll even steal this guy right here. Angle 2, and then root 3 plus 4 root 6, and then hopefully it's going to play nice for us. Let's see. It did. It gave it to us in angles. Let's do one more here. Give it to in radians. So kind of a small 1.23 radians. Hopefully that's it for you guys for this section, and then I'll send you the next section shortly.